Assalamualaikum and hi to all of you beautiful people. Today I'm gonna talk about this digital logic. So let's get into it. Yeah. A little bit of history here. The digital circuitry in digital computers and other digital systems is designed and its behavior is analyzed with the use of a mathematical discipline known as Boolean algebra. The name is in honor to George Boole. Yeah, there's a little bit of our sketch of him, who was an English mathematician, and he proposed the basic principle of this algebra in 1854 in his treatise, an investigation of the laws of thought, on which to found the mathematical theories of logic and probabilities.
So let's move on to basic logic gate. For the fundamental building block of all digital logic circuit is the gate. Logical functions are implemented by the interconnection of gates. A gate is an electronic circuit that produces an output signal that is a simple Boolean operation on its input signal. So the first one is the AND gate. A high output which is one result only if both the input to the AND gate are high. If neither or only one put to the AND gate is high, a low which is zero output results. Next is negative AND gate. The output is complement to the AND gate. And this is OR gate. A high output which is one result if one or both the input to the gate are high. If neither input is high, a low output results. And the next one is NOR gate. NOR gate is the result of the negation of the OR operator. A high output result if both the inputs to the gate are low. If one or both input is high, a low output results. Next is NOT gate, often called an inverter. It has only a single input with simple behavior. If the input is true, then the output will be false. Similarly, a false input results in a true output. Lastly is exclusive OR gate. That gives a true high output when the number of true input is odd.
Let's take a look on this Boolean operators table. For the P column, it starts with 0, 0 and 1, 1. For the Q column, 0, 1, 0 and 1. When it is not P, there is a line above the letter P, and it will be the opposite from the first column P, as in the first row of column P was 0. Thus, the first row in column not P will be 1. Same goes to the other row of the entire column. For column P and Q, the first row is 0 because both P and Q is 0. Same goes to the other two rows because one of them is 0. Therefore, both of them, P and Q, must be true, which is 1. However, it's a bit different from column P or Q. The first row is 0 because both of them, P and Q, is 0. But the result of the other row is 1 because one of them is true. For P, NOT and Q, the result is opposite of the P and Q. When it is 0, the result is 1 and it lies to the other row. Same goes to P, NOR Q. The result is opposite. Okay, let's try one question here. Construct the truth table and draw the graphical symbol of the following question that is colored in red. First, rate column A, B and C with 8 outcomes. Then make it one by one according to the equation. First, we make the not B column, then not C. After that, it's B and not C, which is both of them must be true to get the true result, which is 1. Another column is not B and C. Same rules as column B and not C. For this column, it is read as B not C or not B C. The rule is when one of them is 1, the result will be 1. Therefore, this is the output of the equation, which is A and B not C or not B C, where both of them must be 1 to get the result of 1 as well. Okay, next is to draw the graphical symbol. Let's label it first. For B not C or not B C, we label it as 1 and A as 2. First, draw the graphical symbol of not C and it meet with the B and draw the and symbol. Same goes to not B C. Then both of them meet up together and draw the OR diagram for B not C or not B C. Lastly, they meet up with the A and draw the AND symbol. Then there you go, the graphical symbol diagram for the equation.
So let's go to sum of product. The sum of product form expresses that the output is 1 if any of the input combinations that produce 1 is true. We can also say that the output is 1 if none of the input combinations that produce 0 is true. Thus, this formula can be written using a generalization of De Morgan's theorem. This is the diagram for equation f plus not a b not c plus not a b c plus a b not c. Next is product of sum. This is in the product of sum form. For clarity, NOT gates are not shown. Rather, it is assumed that each input signal and its complement are available. This simplifies the logic diagram and makes the inputs to the gates more readily apparent.